Hello, so in this video we're going to talk through the vector product or the cross product. They're the same thing, they're just called different names because it's called vector product because the result is a vector, or it's called cross product because the way which we write it is with a cross, okay? But again, we're still talking about ways which we can multiply two vectors together. So in this question we've been asked to find the vector which is perpendicular to u, which is 7, 2, 5, and v, which is 2, 7, and 8, okay? So in order to do this, I can use the vector product because you remember by default, the vector product will always give you a vector which is perpendicular to the two vectors that you are using. So the way which I remember it is using my hand, okay? So if one of my vectors is my forefinger, and you can kind of just see it's in the camera there, okay? So it's kind of coming towards you. And if I let another vector be my second finger, so you see that second finger there, okay? So basically these are two vectors. Now obviously, just imagine that these two vectors are lying flat in a plane, okay? So they're not kind of one above the other, they're kind of flat and they're starting from the same points, they're flat to each other. Then the vector perpendicular to it will be my thumb, okay? So you can kind of see the sort of arrangement there, okay? So you can kind of see the arrangement that the thumb is basically always going to be perpendicular to my other two vectors, okay? So that's the idea here. So how do I actually do this? Well, I'm going to be using something called Determinants of Matrices, and I'm going to be using a 3x3 matrix. Now, if you're not comfortable with determinants of matrices yet, that's fine because there's going to be a theme. The next theme is all about matrices where we'll get really comfortable with that. So you might not be comfortable at the moment, but you will be by the time we get to the next theme. What I would also say as well is that there is a formula, and the formula will be in the formula sheet, so you can just apply it using the formula if you wish, but I personally find it easier to remember the kind of pattern which we use when we're using determinants of matrices. So first things first, I need to write my matrix out. So I'm going to put IJK along the top row. I'm going to put my U components along the second row, so 7, 2, and 5. And my V component is going to be along the third row, which is 2, 7, and 8. Now it is important what order you're doing it in. So in this case, I put U along the second row and V along the third row because I want to do U cross V. If I wanted to do V cross U, I would put V in the second row and U in the third row. So just be careful about the order there, okay? You notice as well that I'm using these lines. I'm using these sort of these vertical lines here. That just basically means a size. Now in this case, the size of a matrix, I'm kind of meaning the determinant, okay? So in order to work out the determinant, here we go. What I need to do first of all is I need to take this I and multiply by the determinant of this remaining matrix. So this I almost rules out the rest of that row and the rest of that column. So I basically need to take I and multiply by the determinant of the matrix which I've boxed around. So it's 2 times 8 minus 5 times 7. Okay? Then I need to move across to the j. So if I move across the j, I need to be a little bit careful here because I'm going to make sure I put a negative in front of the j. So negative j, and then times by, well, I rule out the rest of that row and the rest of that column. And it basically take the determinant of the thing which is left. So if you can almost imagine the thing which is left, the 7, 5, 2, 8, is the remaining sort of 2 by 2 matrix. Let's take the determinant of that. So it'll be 7 times 8 minus 5 times 2. Okay? And then finally, I move across the k, so I'm just going to put it down here, plus k. And then times by, well, if I move across to the k, let me just get rid of my constructions. There we go, so if I move across the k, I rule out the rest of that row and the rest of the column. So I basically take the determinant of the matrix which is left. So in this case, it's going to be 7 times 7 minus 2 times 2. Okay, so then I can go back and I can actually calculate these things to tidy up. So I times by, well, if I have a look at that bracket there, I get 16 minus 35. Well, 16 minus 35 is equal to negative 19. So my first component is negative 19i, okay? My next components, let's just tidy this up. Well, 7 times 8 is equal to 56. And then if I take away 5 times 2, that's 10. So therefore, I'm going to end up with minus 46j as the second component. And then the last component, so again, just looking at this bracket here, I get 7 times 7, which is 49, minus 2 times 2, which is 4. So 49 minus 4, that's 45. So I end up adding 45k. Now, this is my this is the vector which is perpendicular to my u and v, but you notice that u and v was given as a column vector, not in terms of I, j and k. So just for practice, I'm just going to say that the vector which is perpendicular to u and v, in other words u cross v, is going to be equal to, well, just putting it back into column notation, it's negative 19, negative 46, and 45. Okay, so that would be the vector which is perpendicular to u and v. Okay? Okay, so next question then, same idea, but we're looking at it from a different perspective. So we've been given that u is just ab1, where a and b are just integer, or they may not be integers actually, they're just numbers, okay, they're just constants. And v is equal to 2, 1, and 5. Now I've been tasked to find the value of a and b such that when I take the cross product of u and v, in other words I find my perpendicular vector of u and v, I get 1, 3, negative 1. So I'm just going to set it up and say, okay, let's imagine that I did know what a and b was. How would I take the cross product? Well, it should just be the determinant of this matrix here. So I set up ijk. Now be careful here, because it's u cross v, it means that the second row must be u, the third row must be the components of v. So the second row is the components of u, which are a, b, and 1, and the third row the components of v, which are 2, 1, and 5. So I'm just going to go through and actually just work out, so if I did know what a and b was, let's actually just write down what the cross product would be. So first things first, I'm going to take I, rule out the rest of the row and the rest of that column, and take the determinant of the remaining matrix. Okay, so this is going to be I times by b times 5, which is 5b, take away 1 times 1, which is minus 1. Okay, then I move across the j. Now remember that I need to put a minus in front of this, so minus j. So if I rule out the rest of the row and the rest of the column, I take the determinant of the remaining sort of matrix. So it's going to be j times by, well, a times 5, which is 5a, minus 1 times 2, which is minus 2. Okay, and I'm going to add on k. So then if I move across to my next one, which is k, so let's just get rid of my constructions again. Rule out the rest of the row, the rest of the column, and look at the determinant of the resulting matrix, or the remaining matrix at least. So that's going to be k times by a times 1, which is just a, minus b times 2, which is 2b. Okay? So that means then that I should be able to say, when I put this back into column notation, so let's have a look, 5b minus 1, and I end up with negative 5a plus 2, because I'm multiplying through by negative 1 here, okay? And then on the bottom, I end up with a minus 2b. What I want is that this is equal to the 1, 3, negative 1, which I want it to be equal to. Okay, so 1, 3, negative 1. Okay. So what that means then is I have a system of simultaneous equations to solve. So I can say that I have 5b minus 1, that should be equal to 1. I have negative 5a plus 2, that should be equal to 3. And I have a minus 2b, that should be equal to negative 1. So let's see if we can solve this, okay? Well, first of all, you realise that from the top equation, I can just solve straight ahead that 5b must be equal to 2, which means that b must be equal to 2/5. Okay, so that's b. Got that straight off. And then if I look at the second equation, I should be able to find a. So I should be able to say that 5a should be equal to negative 1, which means that a should be equal to negative 1 over 5. Okay, so that's the value of a and b, and obviously you can check it in the bottom one. You can check that negative 1/5 minus 4/5, that should be equal to negative 1, okay, which makes sense. All right, so there you go. So I'm basically saying that in order for these two things to be satisfied, if I'm order to find a value of a and b such that I get a vector which is perpendicular to both of u and v, being 1, 3, negative 1, then I can say that a, the value of a, must be equal to negative 1/5. Notice I'm not underlining a because it's not a vector, it's just a constant. And b must be equal to 2/5 in order to get that perpendicular vector.